Welcome. So in today's video I am going to talk about how to count the number of relations. In previous videos we have seen that what is a reflexive relation, symmetric, anti-symmetric, and different kind of relations. But we are going to look at a process today that how to count them, the number of relations that we can define on a set with n elements, that we are going to learn. It is very important especially for competitive exam. So watch the video till the very end to get the better idea about the things that we are going to talk about. If you are new to the channel, please do subscribe it and share with your friends as well. So let's start. First of all, before I talk about counting the total number of reflexive relation, I hope you are aware that if I have a set A with n number of elements, right? This is how we represent a set with n number of elements. Then total number of relations possible will be 2 to the power n square. And how do we get that? We get that because the relation is defined as a subset of the Cartesian product between A and A. Now the total number of elements in A cross A will be n into n, that is n square. Next, we also know that if we have a set with n square elements, then total number of subsets possible will be 2 to the power n square, and that is why we have total number of relations that we can define on a set with n element is equal to 2 to the power n square. So I hope this is something that you already know. One more thing that I want to talk about is how to write the matrix representation of a relation. I have discussed in detail in the previous video related to the matrix representation of a relation, but still, just for your quick reference, I am going to quickly highlight that how to represent a relation through the matrix. So suppose we have a set which contains 3 elements 1, 2, 3, and on this suppose I define a relation which I am representing by 1, 1, 2, 2, 2, 3, and suppose 3, 1, right? Now to represent this relation through the matrix, first of all we need to highlight that there are 3 elements. So there will be 3 rows and there will be 3 columns in this matrix, right? So the matrix representation of a relation which has been defined on a set with 3 element will be a 3 cross 3 matrix. So this is the first observation, right? So in case if we define a matrix or if we define a relation rather on a set with n number of elements, suppose I say the number of elements in A is equal to n, then its corresponding matrix will have n into n, that is n rows and n column, means it will have n square number of elements. Here it will have 9 number of elements. So how do you represent this? 1 is present, so you put a 1 here, right? 1 is not related to 2, so you put a 0 here. 1 is not related to 3, so you again put a 0. Now 2 is not related to 1, so you put a 0. 2 is related to 2, so you put a 1, and 2 is related to 3 also, so you put a 1. And 3 is related to 1, so you put a 1, and 3 is related to 2, no, and 3 is related to 3, no. So this is the matrix representation. One thing you noted here, that in the relation there were total 4 elements, so in the matrix representation of it we have got 4 ones and rest of the elements are 0. Fine. Now the next thing that we are going to talk about, that how to count the number of reflexive relation. So suppose that we have a set A and the number of element in the set A is equal to n. So if I write the matrix representation and suppose we have a relation R which is reflexive, right? This relation R, suppose I say is reflexive. I hope you know the definition of a reflexive relation, that a relation on a set A is called reflexive if A comma A belongs to R for all the elements A that belongs to the set A, right? Now the size of the matrix will be n cross n, And since it is a reflexive relation, I hope you agree that all the diagonal element, if I look at the diagonal element, every element along the diagonal must be 1, because all elements of type A is like, if I have n elements, so 1 will be related to 1, 2 will be related to 2, 3 will be related to 3, 4 will be related to 4, n will be related to n. So all the diagonal element must be 1, right? Take a pause and think about it. Now, since all the diagonal elements are going to be 1, so how many ways are there to put all those ones along the diagonal element? And I hope you will agree that there is just one way, right? Just one way to put all ones along the main diagonal. I hope you agree. Main diagonal. So there is just one way, right? Now, if I say that total number of elements along the main diagonal is equal to n, because it is an n cross n matrix. If it is a 3 cross 3 matrix, there are 3 elements. So if it is n cross n matrix, there will be total n elements. And how many remaining number of elements will be there? When I say remaining number of elements, those which are lying below the main diagonal and those which are lying above the main diagonal, that will be n square minus n. Now, since we already have got the required ones, because for the relation to be reflexive, only thing that we look for that whether all AA kind of elements are present in the relation or not. I don't care about rest of the entries. Yes or no? So the remaining n square minus n number of places which are lying below the main diagonal and lying above the main diagonal, that can be filled either by a 1 or by a 0, 1 or 0. 1 if that element, like suppose 1 comma 2 element is present, so I will place 1 here a 1 I will place. If 1 comma 3 is present, so I will place a 1 over here, otherwise I will place 0. So these elements are not going to decide the reflexivity of the relation. These elements are immaterial in this case. So either I can place a 1 or 0. So how many ways are there to fill all these different elements n square minus n positions? So the total ways are any place can be filled in 2 ways, right? And so there are how many places over there? There are total n square minus n number of places. So we will multiply to n square minus n number of time. So the number of reflexive relation will be 2 to the power n square minus n. And this is something that you need to remember, very important concept. Yes, I hope you have got this point, that how to count the number of reflexive relation. It is 2 to the power n square minus n. If you have any doubt, please take a pause and rewatch and think about it, that what is the concept that we have followed, right? Next, we are going to talk about the number of symmetric relation that we can define on a set with n element. So again, we are going to talk about the matrix representation of a symmetric relation. And I hope you are aware that matrix representation of a symmetric relation is a symmetric matrix. We have discussed about this in the previous videos. So in case if you have any doubt, please watch that videos as well. Now, if I'm talking about symmetric matrix, means what? That first of all, you look at the main diagonal element, right? If I look at the main diagonal element, total number of elements along the main diagonal will be equal to n, right? And how many elements are there other than the main diagonal, means total number of diagonal element or those which are not lying along the main diagonal are equal to n square minus n. Now, what is the characteristic of a symmetric relation? The characteristic of a symmetric relation is that we must have BA in R whenever there is an AB in R, right? So it means what? That suppose we have an element in ith row and jth column, right? ijth element. So if suppose I say that how many elements are there in the set, let me call those the set A as having elements from 1 to n, right? There are n elements. So ijth element is equal to 1 means what? It means that we have the element like I comma j, right? The element I comma j is present in the relation R, right? Means the element I is related to the element j. So if I comma j is present in R, and if this relation to be symmetric, j comma I should also be present in R, right? So suppose I say that this position is ith row I comma j position, means ith row and jth column. Then this position, if I take the symmetric position, so this position which is the jth row and ith column, if this is 1, then this must be 1, right? If I comma j element is present, then j comma I element should also be present. If this is 0, for that matter, if suppose I say that there is a 0 over here, then this element must also be 0, right? So there are two possibilities. Either both I comma jth position or j comma ith position can be occupied by either 1 1 or 0 0. It can't happen that here you have a 1 and here you have a 0. That will violate the symmetric nature of the relation. Or vice versa also. You can't have a 0 over here and a 1 over here. That will also violate the symmetric nature of the relation. So only two possibilities are there. Either both should be 1 or both should be 0. Now as you have agreed that the total number of elements present in the position other than the diagonal element are n square minus n. So how many pairs are there? If I consider the ijth position and jith position as one pair, so total number are n square minus n. So the total number of pairs are n square minus n by 2. And each of these pairs, means ijth position and jith position, can be either filled by a 1 1 or filled by a 0 0. So to fill each of these ijth and jith position, we have two ways, right? So the total number of ways are 2 to the power n square minus n by 2 to place the elements other than the diagonal element, right? So these are the total number of ways. I hope you got it, because each pair, how many pairs are there? N square minus n by 2 number of pairs are there, and each pair should occupied by either a 1 1 or a 0 0, right? So there are these many pairs and each pair is occupied by two ways. So total number of ways are 2 into 2 into 2 up to how many times? Up to n square minus n by 2 times, which is equal to 2 to the power n square minus n by 2. But then there are n diagonal elements also. So diagonal elements we don't care, because that is not anyway going to affect the nature of the relation. So each of the n elements which are along the main diagonal can be either filled by a 0 or by a 1. So how many places are there along the main diagonal? There are n places, and each can be filled in how many ways? 2 ways. So the total number of ways are 2 into 2 into 2 n times, right? So the number of possibilities are 2 to the power n. So if I have to count the number of symmetric relation, how many symmetric relation will be there? The diagonal elements are placed filled in 2 to the power n number of ways, and off diagonal elements, those which are not lying along the main diagonal, those pair of elements like those n square minus n by 2 pairs of elements are filled in 2 to the power n square minus n by 2 ways. So this is the total count. Some people can also write it, that they can write n square minus n by 2 plus n. So if you simplify, it will be 2 to the power n square plus n by 2, right? Because 2n minus n, so it will become plus n. So this is the total number of symmetric relation. I hope up to this there is no doubt. Next we are going to, so we have talked about three types. First is the total number of relation, that is 2 to the power n square. Then we talked about total number of reflexive relation, that is 2 to the power n square minus n. Here we have seen 2 to the power n square minus n, and the total number of symmetric relation is this. Okay. Okay, so let us count the number of anti-symmetric relation. So to count the number of anti-symmetric relation, again we are going to follow the matrix related idea, because it helps us to visualize the picture in a better way. So if I talk about the matrix representation of an anti-symmetric relation, what is the important point that we notice? The first thing, if you look at the definition of an anti-symmetric relation, its definition says that if A comma B is in R, then B comma A should not be in R unless both A and B are equal. Okay. So what basically it is saying, that suppose we have an element, if I look at the matrix representation of it. So if we have an element in ijth position, if we have an element in ijth position, so I will put a 1 over there. So in jith position, if I write, let me write it like this so that you understand. Suppose I say that we have ijth position, and here I am writing the jith position, ji position, right? So if ij position is a 1, then jith position must be a 0. Because if I comma j element is present, then j comma I element should not be present. Another possibility is that if I comma j is 0, then j comma I may be 1, right? Because if j comma I is present, then I comma j should not be present. Yes, I hope you are getting. And this is another possibility, or third possibility, that suppose both of them are not present, then also there is no problem. Because for the relation to be anti-symmetric, if what is the condition? That if AB is there, then BA should not be there. If AB is not there and BA is also not there, then there is no problem. So that situation corresponds to having ijth entry 0 and jith entry 0. So here there are three possibilities: 1 0, 0 1, and 0 0. Another possibility is that is not possible, that both of them is 1. That possibility is not possible, because it can't happen that ij is also 1, means ij is also present and gi is also present. That is not a feasible thing to happen, because the relation is anti-symmetric. So again, if I say that the set on which I have defined the relation has n number of element, then the matrix representation will be an n cross n matrix, and out of this there will be diagonal elements. So there are n diagonal elements, and how many elements are below the main diagonal and above the main diagonal? So we have seen in the previous problem, or when I was talking about reflexive and symmetric. So there are total n square minus n number of elements which are not along the main diagonal, and out of that n square minus n by 2 are below the main diagonal, and n square minus n by 2 are above the main diagonal, right? So now actually how many pairs are there? So there are total n square minus n by 2 pair of elements, if I am calling the ijth element and jith element as one pair. I repeat my statement. If I say that we have an element here, ijth position, and suppose I say this is the jith position, so if I call them as one pair of element, how many pair of elements are there? N square minus n by 2 pair of elements are there. And through this explanation, we have agreed that this n square minus n by 2 position can either be filled by a 1 and a 0 here, first possibility. Second possibility is that a 0 here and a 1 here. And the third possibility is that here we have a 0 and here also we have a 0. So there are three ways to fill that. We can't fill 1 1. So each of the pair can be filled in three ways. So the total ways are 3 into 3 into 3. How many times? N square minus n by 2 times, which is equal to 3 to the power n square minus n by 2. Now we have n diagonal elements, and these n diagonal elements can be filled by either a 0 or a 1. That does not matter, because if it is 1 also there is no problem, because a kind of element may be present in antisymmetric relation, because if a comma b is in R and b comma a is also in R, then a should be equal to b. So if a comma a is present, that is not an issue. So the diagonal element can be either a 0 or can be either a 1. So the total number of ways to fill the diagonal element is actually 2 into 2 up to n times, because we have n diagonal elements. So the total ways are 2 to the power n. So what is the total number of antisymmetric matrix? So the total number of antisymmetric matrix is equal to 3 to the power n square minus n by 2, right, into 2 to the power n. And this is the total number of antisymmetric relation. I hope you have understood. In case if you have not, please pause the video and check it again. Now let us count the number of irreflexive relation, and here again we are going to use the idea of matrix. Now ladies and gentlemen, as you can see the definition, that a relation is said to be irreflexive if a comma a is not present in R. That should be true for all elements in the subset, all elements in the set A. So suppose again I take that the number of element in set A is equal to n. So how many elements will be there? This will be an n cross n matrix. If I represent the relation on a set with n elements, so its matrix representation will have n cross n matrix will be there, and total number of elements will be n square, right? That is the first thing. We all already clear about that. Now if I look at the main diagonal, it is saying that none of the elements a comma a should be there. It means what? That every element along the main diagonal must be 0. So every element, if I write a 0 here, this is another 0, this is the third 0. So all the n element along the main diagonal must be equal to 0. So if I ask you that if everything is 0 along the main diagonal, how many ways are there to place those 0? So there is just one way. If you have seen the counting of reflexive relation, there I was placing 1 along the main diagonal. So all the elements were 1. And so that also we counted like just one way. Here also, if I am placing all 0, so there is exactly one way to place all 0 along the main diagonal. And now how many elements are left? So total number of elements are n square. N elements are along the main diagonal, so remaining elements are n square minus n. And for the relation to be irreflexive, only requirement is that there should be no AA kind of element. All the elements AA must not be present there. So the remaining n square minus n entries may be anything. We don't care, right? Because the requirement is that we should not have AA type, and that requirement is already fulfilled by placing all the zeros along the main diagonal. So remaining n square minus n position can be filled in how many ways? So any position can be filled in either two ways, 0 or 1. So there are total 2 into 2 into 2. How many times? N square minus n times. So that is equal to 2 to the power n square minus n. So the total number of irreflexive relation, is equal to 2 to the power n square minus n. I hope you have noted this point, that the total number of reflexive relation was 2 to the power n square minus n. So you see here we have proved that the total number of reflexive relation was 2 to the power n square minus n, and in case of reflexive relation, actually there was 1 along the main diagonal, all the elements were 1. In case of irreflexive relation, all the elements are 0, right? Whether the remaining elements are there or not there, that is not a matter of concern. It may be a 0, it may be 1, anything. So the number of irreflexive and reflexive, so both are equal to 2 to the power n square minus n. Now I am going to count the number of asymmetric relation, and the matrix is something that we are using to count all of them. So let us draw the matrix again, and before I do that, let us take the set A with n number of elements, and the matrix representation of any relation which is defined on a set with n number of elements will be an n cross n matrix, right? So total number of elements will be n square. So this we already have discussed quite in detail. Next, here they are saying that what is asymmetric relation? Asymmetric relation is that if AB is in R, then BA should not be in R. Now in the asymmetric relation, we are also not allowed to place those elements which are of AA kind, right? So those elements means basically if you look at a relation which is asymmetric, it should be both antisymmetric and irreflexive. Irreflexive means that there should be no A comma A elements in R. There should be this should be true for all element A in the set A. Means we should be placing zeros along the main diagonal. All the element must be equal to 0, right? Now the remaining n square minus n positions which are there other than the diagonal element. So we are going to look at them in a way that the way we have seen it in case of antisymmetric matrix, antisymmetric relation, sorry. And there we have noticed that if again I take that, suppose I consider ijth position and jith position. So in case of asymmetric relation also, if ijth position or ijth element is present, right, means if I comma j element is present, so suppose I say this is I comma j element, then j comma I element should be 0. If this is a 1, then this must be a 0, means there must be a 1 0 pair. Another possibility is that if there is 1 here, then this should be 0. If there is a 0 over here, then there should be a 1 over here. That is also a possibility, right? And third possibility is that if both of the elements are not present, ijth element is not present, means I comma j element is also not present. I hope you understand that I am considering the set to have n elements, so let us number them from 1 to n, right? So if I comma j element is present, then j comma I element should not be present. If I comma j element is not present, then j comma I element may be present, and if both of them are not present, that is also acceptable. What is not acceptable is that both of them are present, means I comma j and j comma I. That is not an acceptable situation in case of asymmetric matrix, and the diagonal element certainly should be all 0. So how to count now? So the diagonal element can be filled in just one way, just one way, right? I think now you are familiar with this process. And those elements which are not along the main diagonal, so how many elements are not along the main diagonal? N square minus n. And how many pairs are there? N square minus n by 2. If I am considering the ijth position and jith position as a pair. So each pair can be filled in 3 ways, either by a 1 0 or a 0 1 or 0 0. So the total number of ways are 3 to the power n square minus n by 2 and into 1, because diagonal element can just be filled in one way. So the total number of asymmetric relation is equal to 3 to the power n square minus n by 2. And I hope you have noted that it is different from antisymmetric. In case of antisymmetric, we were allowing elements to be either a 0 or 1 along the main diagonal, because antisymmetric relation permits you that if AB and BA are there, then A must be equal to B. So A comma A kind of elements are permitted in antisymmetric relation, but A comma A kind of elements are not permitted in asymmetric relation. So this is another way to remember it, that a relation is said to be asymmetric if it is both antisymmetric as well as irreflexive. So basically asymmetric is a stricter condition than the antisymmetric. In antisymmetric, we were allowing AA kind of element. We were not allowing AB and BA both to be present, but here in asymmetric, we are allowing if A comma B is there, then B comma A must not be there, and at the same time we are also not allowing A comma A type of element, right? So next we are going to count those relations which are reflexive and symmetric. Okay. So let us count the number of relations which are both reflexive and symmetric. So I think by now you are already clear that we are going to start with the matrix representation. So suppose I take a set A with n number of elements, and on that I have defined a relation. So its representation in terms of matrix will be an n cross n matrix. And out of those there will be n elements along the main diagonal. So n elements along the main diagonal, and n square minus n number of elements are other than the diagonal element. Now I want the relation to be reflexive. The definition of a reflexive relation is that we must have all a comma a type of element in the set A, in the relation R for all element A in the set A. So it means what? That I need to place 1, 1, 1 and so on up to, so all the elements along the main diagonal must be 1 for the relation to be reflexive. So if I ask you that how many ways are there to place all the 1 along the main diagonal, just one way. And I am using this term just one way, right? This phrase I am using. So there is just one way. Now, for the relation to be symmetric, I again look at the pairs, like suppose I say that, let me change the color for better visibility. So suppose I say that we have an element here which is coming in ith row and jth column. So and then we also look at the element in jith row and ith column. So for the relation to be symmetric, there are two things that we are going to accept. If there is ijth element is present, then jith element must be present. So that pair is like it should be 1 comma 1, right? I mean, if ijth element is 1, then jith element should be also 1. So this is this pair of element, which is the pair I am calling those elements which are occurring in ijth and jith position. So that pair can be taken as 1 1, or it can be taken as 0 0 also, right? What is not acceptable, that 1 is present, ijth element is present but jith element is not present. That is not acceptable. And this is also not acceptable, that ijth element is not present but the jith element is present, right? So these two are acceptable situation, that if for the relation to be symmetric, if a comma b is there, then b comma a must be there. If a comma b is not there, then b comma a should also not be there, right? So either both should be 1 1 or both should be 0 0. So as you have seen that total number of elements are n square minus n. So total number of pairs are n square minus n by 2. And each pair can be filled in two ways, either by a 1 1 or a 0 0. So the total number of ways are 2 to the power n square minus n by 2. Right. So this is the total number of relations which are reflexive and symmetric. Finally, we are going to talk about those relations which are both both we already have counted. Now we are going to talk about those relations which are neither reflexive nor irreflexive. So it is very easy to count, because we have already counted the total number of relation, that is 2 to the power n square, right? That was the total number of relation that we can define on a set A with n number of element. And from that I am going to subtract those relations which are reflexive. So total number of reflexive relation are 2 to the power n square minus n, and total number of irreflexive relation are also 2 to the power n square minus n. So total number of relations which are neither reflexive nor irreflexive is 2 to the power n square minus 2 into 2 to the power n square minus n, right? So this gives us the total number of irreflexive as well as means total number of relations, sorry, let me rephrase, total number of relations which are neither reflexive nor irreflexive, right? So now let us summarize the things that we have discussed. One thing that we have discussed is that total number of relation is 2 to the power n square, and that we have discussed in earlier videos also. Now how many reflexive relations are there? So we have counted the total number of reflexive relations are 2 to the power n square minus n. How many symmetric relation are there? So we have counted, it is 2 to the power n square plus n by 2, which is equal to also written as 2 to the power n into n plus 1 by 2. We counted total number of anti-symmetric relation, and what was the total number? The total number was 3 to the power n square minus n by 2. Right, let me rewrite it possibly. So it was what, 3 to the power n square minus n by 2 into 2 to the power n. So that was total number of anti-symmetric relation. How many asymmetric relation was there? It was 3 to the power n square minus n by 2. How many irreflexive relation were there? So total number of irreflexive relation were I think we have counted. Irreflexive was 2 to the power n square minus n. Means reflexive and irreflexive both are same, 2 to the power n square minus n, and here also 2 to the power n square minus n. And you have noted the difference also. In reflexive, all the diagonal element must be 1. In irreflexive, all the diagonal element must be 0. Those relations which are reflexive and symmetric both, so we have counted them, and it was 2 to the power n square minus n by 2. And finally we counted those relations which are neither reflexive nor irreflexive. So it was total number of relation 2 to the power n square minus 2 into 2 to the power n square minus n, because we subtract the total number of irreflexive as well as reflexive relation from the total number of relation. So I believe I have put a lot of effort in this video, and I was thinking of creating this video from quite some time, and I hope I was able to explain to you the ways of counting different kind of relation. Some of you might be thinking that, sir, you have not counted the number of transitive relation, because there is no such formula, there is no general formula available to count the number of transitive relation, right? So please share this video with your friends, because this is an interesting thing, and I personally feel that this was very interesting to count the things. I believe that you must have enjoyed the video, so press the like button, and keep sharing and keep watching, so that you get a better idea related to the discrete maths course. That's all from my side for this video. Thank you and have a great day.